All right, so I got the thing working, the thing that splits up paragraphs, and I tested it with an adversarial example, which is these long paragraphs from James Joyce. It's in the public domain, so I don't have a problem with using it. And we can see when it splits up, we end at a word boundary, which is about the best we can do because it's a single sentence. There's no punctuation to set us off or to indicate that that's a good place to stop. And so that algorithm works. At the end of my previous video, I had asked the Gemini AI to try and come up with an algorithm to do this. And what I found was that the algorithm it made up wasn't great. So instead, I instructed it to try the following. We'll just go to about 1,000 characters into the long paragraph, and then the next 50 characters after that, we're going to look for some sort of paragraph boundary. If we don't find a paragraph boundary, we're going, or rather, we're going to look for a sentence boundary. If we don't find the sentence boundary, we're going to look for a clause boundary, like a semicolon or a comma. If that doesn't exist, we'll break at any word. And then if that doesn't work, we'll break arbitrarily. And so where is that? That's in text splitter. I probably should look for a paragraph boundary. I guess that's probably going to show up that there will be some like p tag or whatever that has new lines in it. So I'm going to go ahead and ask the AIs to suggest how to do that. Probably just adding to this regular expression, or possibly adding a new one before it. I'll say in this code, add a before checking for a sentence boundary, check for a paragraph break. For example, new line or carriage return. So it's starting by checking for the, it looks like it's starting by looking at the start of the string. Oh, no, hang on. We're going to look at the substring from start to search end, and if it contains this or it contains that, then we're going to, I guess, get a new regex and match it. And I guess I'll ask, why do you need to use a regex after calling contains? Can't contains or a similar method give you the index of the paragraph break? Okay, so that seems pretty reasonable. Let's go ahead and update these numberings. And we'll see if the tests still pass, which they should. They might break at different places. I think this text does contain paragraphs, but I'm not positive. So search end isn't a thing that exists. I guess it's looking for end. Okay, and so just scrolling through, we see that it is breaking at word boundaries, so that's good. I don't want it ever to break mid word. And scrolling through, it looks like there are paragraph breaks, and I'm not sure if they are, if they were put in there by Joyce or by an editor. So surely they are should be the end of one. Okay, so it does break here. It looks like, does it? I think so. And then I don't know why this is a single line. That's kind of interesting. I guess that's an edge case. Let's look at another example and see if it does that too. I'm sure you were with no apostrophe for the I'm. Yeah, okay. So it looks like after it breaks here, it doesn't give you a full paragraph for the next one. So let's take a look at the code and see if we can figure out why that is. Close a bunch of these extraneous files. So if we find a new line, we return carriage return index start plus 1. That's the return value of find nearest boundary. And then this is being called with split index 50. That's the search radius. Let me take a look at this output again. So let's grab this and count it. I don't know if there's an easy way to count it in Android Studio, but we can pop it into Emacs. Hey. Command insert. Why is command insert yank on the Emacs key bindings? So 758 characters. That is less than 1,000. So somehow after this call to find word boundary, find nearest boundary, the leftover text isn't splitting properly. So we get boundary index, we add paragraphs, the substring from current position to boundary index, and then we trim the white space. And then we set the current position to boundary index. And boundary index is less than text length. So we should go down here again. We split it here, looking for target cars, which should be about 1,000. Stop that. And split index is still less than text length. And we call find nearest boundary again. And so is there anything special about where it's ending? I'm wondering if it's counting these two as one group of 1,000, that is. Not coconut words, count words. Okay, so we get about 1,003. So it seems like what we're doing is we are splitting it here and then splitting it again here. Or maybe we're not grabbing, maybe we're not doing anything and that carriage return is just part of the string, which is maybe what's going on. So let's try commenting out that piece. Yeah, I think that's what's going on. All right, so we don't want that. How do we get rid of that? Something is wrong about this algorithm. So we're going to look to see if there's an index here. Let's create an artificial one out of this generic text. So this actually doesn't look so bad. Although we do get this short paragraph. And just so we can like visually index into this better, let's choose some other English text. How about uh, I'll just grab a random selection from the speeches of Cicero and delete all the new lines, or rather delete some of the new lines. I guess the Emacs key bindings aren't perfect. Oh, you know what? This might be my fault. I think that I maybe added my own new lines because I wanted it to fit in an 80 character window. So why don't I see if I can unbreak this, and maybe that's an artifact. No, seems fine. Okay, but it does look like it looks like it's mostly breaking things up properly. Okay, so produced and published is broken up, but now it's in its own line, and I guess that's because after it we have a return. But we're still getting the same effect where the thing after the carriage return is broken too early. I'll try asking the AI why it's breaking too early. So in this implementation, it correctly breaks at new lines, but the paragraph after the new line break is shorter than the other paragraphs by the size of the, now I'll just say what can cause that. So it says it's likely due to how it handles the current position variable after finding a new line character. Here's the problem. When the new line character is found, find nearest boundary returns the index of the new line character itself. What is it supposed to return? Oh, okay. This means that the next iteration of the loop starts at the new line character, effectively including it in the next paragraph. No, I don't think that's the issue. So I just told it in words what the problem was. You are absolutely right. My previous explanation and solution were incorrect. The issue is not with skipping the new line character, but with how split index is calculated in the next iteration. If a new line is found at index 100, the first paragraph will correctly have a size of 100. Current pause update. The current pause updated to 101. And split index, the next iteration split index is calculated as the current position plus target characters. If target characters is 100, the split index would be 1001. This leads to the second paragraph being shorter than expected because the search for the next boundary starts at 1001 instead of, 1101 instead of 1001. To fix this, you need to split. Yeah, that makes sense. You need to reset split index to target cars after finding a new line character. Oh. Where is split index? Here. I'm not sure this is the issue either, because target cars should still be 1,000 away from where we are resuming. It seems like when we find a match, we're looking at the end of the match and adding start to it. I don't really see. It's not obvious to me what really is going on. So let's create a smaller version of this. Okay, so this is more of a minimal criminal. And instead of printing in the test, let's print here. So we'll just create a log, do some printf debugging as a start. I guess I need to have strings here. No. Okay, so it looks like it's not even logging the stuff here. So I think it's not actually splitting at these these new word boundaries. So substring, okay. So that's just creating the substring. Index of is what? -1 if no match. Returns the position of the first match of pattern in the string starting at start, inclusive. First of all, I don't think we need to, well, whatever. Oh, I think it's because we're indexing it, we're getting the index into a substring. Is that the problem? So let's try this. So let's try adding start here. Start should be the index into the overall string. And there's no end here. So I guess we'll check here if new line index is less than or equal to end, we will return, I think, new line index plus start plus 1. This looks more promising. Although now the paragraphs look too long. I don't know if that's because my print statement isn't great. So let's add printing back here. Although now we are not splitting on a word. Okay, now we have, no. Still the same problem. So I think that maybe it's about this stuff. So we're starting the index at start. We get some index back. We check whether the index is I think we want to check that it's not -1. That's certainly one bug. I don't know if that's the whole thing. Better, better. But now we're still stopping at Aurelian laws, which is not 1,000 characters. Although none of these really look like 1,000 characters. Ten 25, 952, about 776, and 1034. So, what's happening at some point is either we're not splitting here, or something else is bad happening. So, how about if we discover a new line? If we're done here, let's print a signal saying that we got here. Okay, that didn't work. Let's just try adding a debugger point here. So start is 1,000. Why is start 1,000? Because, wait, what? So, okay, so here target characters is 1,000. Split index is 1,000. It's smaller than the text length. So we're going to call find nearest boundary. We'll step into that. Now, why is start 1,000? So here, we correctly start at current position 0. Oh, I guess that this does make sense. We're going to start at the 1,000th character and look in the next 50. And that's why, because the new line is before where we start looking as we've indexed into it. That makes total sense. And now the question is, does it matter? I guess it does seem nicer to have to, it does seem like the right way to do it is to be able to split at paragraphs. but inside of this method is not how to do it. So let's see if I can git revert this. And what I want to do instead is in split text into paragraphs, before calling this nearest boundary, the nearest boundary is for inside of a paragraph. So I think we have maybe an outer loop to deal with. In this code, split text into paragraphs correctly splits long paragraphs into subparagraphs. Add by calling find nearest boundary. Add an outer loop to first split text into already delimited paragraphs by looking for new lines and carriage returns. Okay, so it's going to try to text split at the regex to get delimited paragraphs, and it's iterating over them. Okay, that seems pretty reasonable. I accidentally created a new file. I guess I clicked the wrong button. All right, I don't know if this is valid code, but we'll try to run it and see what happens. Okay, so now this should be hopefully now about 1,000, 1,034, 1,050 or so. Yep, 1,005, perfect. Okay, so now that bug is gone, and I feel better about it. We can verify that the Ulysses stuff looks good. Okay, so these paragraphs look less raggedy. Okay. Well, that took slightly more effort than I thought it would, but not bad. I'm going to go ahead and update the git commit and push it so that it's. And let's get fast forward and rewind working. So I guess where I started that is that for fast forward and rewind, we want to have these audio cursors somewhere, or rather, audio place. And I don't know where that is. Okay, so if we're playing, then we're going to get the text. And here it says we're going to speak it. But before that, let's wait. I could have sworn I added an audio places variable. Is it because I stashed? I only meant to stash that one file. Hmm. I'm not sure how much of that I caught. I might have had my microphone muted, but I realized that I need to re- record the text spans. Uh, the indexes rather. So I'm asking Gemini to rewrite it to do the bookkeeping for me. This is looking promising. We have a global offset here, which is essentially how I was planning to do it, and we initialize it to the paragraph start at the beginning of the for loop, and then in the while loop we should update the global offset somewhere. Okay. So let's try to see if that works. We'll run the test. The test doesn't test any of the stuff that you would want to make sure that this is correctly slicing up the text spans. But we'll just see if it runs at all. And if it does, I can touch up any of the tests later. I kind of just want to move along and stop fiddling around with this. Okay, so this needs to be changed in type. Okay, so the logic that actually splits into substrings seems to be working. Let's just assume that the text span boundaries also work. And I'll grab this 1000 and turn it into a global variable. What's the style for global variables? I guess seems to be still lower camel case. Okay, so now we have some text views. I mean some text spans. And what do we want to do with them? Well, we want to add them to the audio places. I think my to do style is capital. Okay, so then we have this audio place, and that's that. And then instead of calling text to speak, Flutter TTS speak on TXT, we're going to call it on audio places at current index dot text spans at what? We could call it at 0, but what we need is a cursor into the text spans, or an index into the text spans. And let's keep that in the audio place. Or should we? Can I do this where I have a default argument with another constructor? I guess so. No? Maybe not. Okay, so how do I add a name? I guess I can't call it new. Okay, so I can create a new one with the text span cursor set to 0. And then if I want to get the text back out, I have to, I guess, assert that the text spans are not 0. But I don't think that's what I need to assert. I think I need to assert that the list element is not 0, right? Or maybe that the, okay, so audio places. And then I don't know what the lookup syntax is like for a linked hash map if you're not sure whether the thing is populated from iterable, from iterables, from entries. So the indexing operator returns null if the key is present. This implies that the return type of the operator must be nullable. So I guess it just returns null. Is that all I have to do? And then there's probably some syntax to like add a question mark, and if it's okay, so we'll do like audio places at current index question mark dot text spans at text span index. Now that I think about it, let's not have the text span contain the text span index. Okay. So instead of always computing the text spans here, what we should do is we should look in audio places. If audio places dot at current index. I guess we can just do a null check here. If not that, then we are going to get the text spans. Okay, so if it's not null, then we're going to add it, and if it then if we're down here, we are going to get the text spans, which can now be final. And we have to check if the so if right, we have to roll over to the next text span, possibly. I don't want to have to do that here. But I guess I will. So if text span cursor text span index rather. So if text span index is greater than or equal to text span, whoa, text spans dot length, then we've fallen. Then we're just going to set current index plus or equal to 1. And we'll set text span index to 0 because we're now at the 0 of the next text span. And then we'll call continue. Otherwise, we will we'll just speak the thing at the text spans cursor. Text span index rather. And then after we speak that, we're going to move the audio cursor. But now, So let's move the audio cursor once we roll off the end of the text span length. And then we'll wait for the text to speak future. Okay, so that's a bit convoluted, but that's play. There's probably bugs in here. Should I see if it works? I guess I should see if it works. Okay, so it didn't like this. There's some, I made a null, not null assertion on a thing that's null. And why doesn't it like that? While it's trying to run in the debugger, let me take another look at this. So audio places can't be null, if I'm understanding correctly. Yeah. So, oh, this should be if it is null.
Zero, 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 zero. Zero, one, two, three, 4, 5, 6.
Okay, so far so good. And now we need to handle the seeking left and the seeking right. So what do? I told, okay, so I started implementing this. So I told Flutter TTS to stop. And we're going to add seek to the current index. And that's not what we should do. This is going to have to be a little bit more difficult because we have the index into the text spans. And frankly, I don't really want to have to implement this, but I will. So to start thinking through it, I'll do two cases. One if seek is less than 0, which is rewind, and the other if seek is greater than 0. So if seek is greater than 0, then while seek is non-zero, we are going to we'll make copies of the current index of the text span indices. And while seek is non-zero, so in this condition, seek is also positive, so we're fast forwarding. We're going to first exhaust all of the text span indexes. You know what? We can't do this. We can't do things this way because uh, the audio places might not be populated at this index. So what that means that if I'm lazily loading the text into the audio places, then fast forward and rewind um, may take some time because we have to compute what's in those indexes. So I could see a few obvious things to do here. I could make a lazy audio places type that has an interface where the caller doesn't have to worry about loading stuff into the audio place. I can also I can do a few other things. And I could, for example, try to preload some stuff. And I guess the more that I have to, what's the downside of lazy loading? The downside of lazy loading is that occasionally fast forward and rewind is going to cause it to do work. What's the downside of greedily loading? It is that the document might be really long, and so we may do a bunch of work when it doesn't need to be done. So, for example, if the document is an entire novel, then probably the audio place stuff doesn't need to be there. I guess I'm leaning towards creating a lazy audio place and essentially taking this thing that checks if it's null and moving it somewhere else. But this functionality is really depending on getting the text from the web view. And so I think that the lazy audio place would have to have a reference to the web view. Let's see if we can extract this as a method. So I'll have an extremely long name, and I'm doing that for a reason, which is the other names I can currently think of don't really convey what this means, and then I'm going to forget what it means if I don't have this here. So just until I get the hang of how this should go, I'm going to give it this long, terrible name. So it's going to read at the current index and populate the audio place. And so after this function is called, the audio place is at current index is guaranteed to be non-null. Is that true? Well, hopefully it's true, unless there's some sort of error. Not only non-null, but also and to contain the all of the text spans at the current index. You could imagine it being non-null, but also not ready to be used. And instead of calling it read current index, read is ambiguous because we're doing text to speech. I'll say load text at, just to make it even longer. And in fact, this whole thing should be wrapped in an if statement, I think, right? So we only need to do this if the current index is non-null. Otherwise, we're going to assume that at least in this function, we're going to assume that the text is not changing. And so we only need to populate it once. And so if the text is already populated, this is a pretty cheap operation. Okay, and now we can call this here. We'll guarantee that this is non-null. So we should be able to get the text span lengths. And as long as we are currently strictly less than, we are going to increment it. And we also need to, hello. No, await. Where? Yeah, we should await. Thank you. Thank you, idle piece. Okay.
0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 5, 6, 7, two, 3, 4, 0, 1, 2, 3, 4, 4, 5, 6. Quote quote, quote quote, quote quote, quote quote. 0, 1, 2, 3, 2, 3, 2, 2, 3, 4, 3, 4, 3, quote 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 quote. 0, 1, 2, 3, quote 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 quote. 'Quote quote, quote quote, quote quote, quote quote. Zero, one. Quote quote, quote quote. Quote quote. Quote quote. 0 1 quote 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 quote